might be knowing that the king Porus in 300 back centuries gifted a very precious item to the Alexander the Great, and the precious item was iron. This lecture intends you friends to introduce about ancient iron making in India. There are many archaeometallurgical evidences in the country which show how rich our ancestors were about the technology, science and art of the ancient iron making. So let us start with process description of ancient iron making. Actually, the ancient furnaces were very small shaft furnaces, and the furnaces were charged from top. The charging material were iron ore and charcoal. The air was blown from the bottom with the help of bellows. Actually, there is similarity between the ancient iron making as well as the modern blast furnaces. The charged materials were charged from top in modern blast furnace also, and air is supplied through the bottom, which we call blast, air blast. Now let us discuss about the furnace design. Across the country there is variation in the height of the shaft furnace, but in Jharkhand, Bihar, Bastar, Madhya Pradesh, in these regions the height of furnaces were smaller. The diameter at the bottom, it has been found that it is around 50 centimeter, and the diameter at the top of the furnace, it is about 15 centimeter. The furnaces were made by local clay, basically white clay, and it was painted from inside the non-shrinking type of same clay. The bellows from where the air was supplied, that was basically foot operated. You will also see through the animation how the bellows were operated. The raw material was taken from open cast mine, not going into deeper, and for charging into the furnace, the size was maintained around 10 mm. The iron ore was basically laterite or limonite. Charcoal was prepared locally, and the size of charcoal was maintained around 25 mm, 2.5 centimeter. Initially, the furnace was filled with charcoal. The raw materials were charged into alternate layers. 15 kg of iron ore and 25 kg of charcoal were charged from top. The air is blown from the bottom, and so the charcoal was ignited to produce carbon monoxide. Meanwhile, after an hour, the temperature reached up to level of 1100 to 1200 degrees centigrade. The first slag appears after 1 hour, and the complete reduction takes place after 4-5 hours. After the reduction of iron ore, the air supply is further increased to further increase the temperature, so that the slag will come out in liquid form. So it has been found that initially 2 kg of slag, that is phyalite, 2FeO.SiO2 comes out. Finally 3-4 kg of sintered sponge iron is produced, and this sponge iron has many impurities as well. The entrapped slags and unreduced FeO both were present in that iron. Theoretically, there are two kinds of reduction: direct reduction and indirect reduction. the reduction which is carried out by carbon is called direct reduction, whereas the reduction carried out by carbon monoxide is called indirect. This indirect one is exothermic and direct reduction is endothermic. You can see the screen where these two kind of reactions has been shown. Another reaction which is very important is Boudard reaction, CO2 plus C equal to 2CO. It has also been found that when carbon monoxide to carbon dioxide ratio is 4, the furnace operation is best. Carbon monoxide is more stable at high temperature. As the temperature increases inside furnace, the silica as a gang present in the iron ore forms phthalate. Phthalate, that is 2FeO.SiO2. It is the slag, and at high temperature it comes out as liquid state. Another advantage of this high temperature is that at 1200-1250 degrees centigrade, delta iron is produced, which is lesser in content of carbon. So the ancient iron making process was able to produce the iron having less content of carbon. As the reduction was carried out by charcoal, there was no chance, or rather little chance, of sulfur pickup in the final iron, whereas the phosphorus content was more, because all the phosphorus present in the iron ore were picked up during the process. So the final product contained less amount of sulfur, but the phosphorus percentage was about 0.1%. The hot sponge iron taken out from furnace and it is sent for secondary treatment. Secondary treatment is important because this sponge iron contains a lot of slag particles. By hammer forging, these slag particles squeeze out and the sponge iron becomes free from slags and forms a solid iron rod. These iron rods have higher density than the original sponge iron. This can be further refined to produce weapons or other kind of applications. Friends, we have two eminent experts of this area, Professor Bhanu Prakash from Banaras Hindu University and Dr. A.K. Vash from National Metallurgical Laboratory, Jamshedpur. We have a group of students, they have some doubt, they want to clarify it. I welcome all of them. So let us move to our experts to know about what was unique in the ancient iron making.
The uniqueness of making process is that it was developed about 6,000 years back by tribal artisans of India. It makes use of low-grade iron ore, which are available on the surface of the ore and they are porous in nature. It makes use of charcoal as reductant, whose ash content varies about 4 to 5%. The equipment or apparatus involved for making ancient iron making is made of mud and it is very cheap. It is almost cost-wise, it is almost nil. This process is slagless process and the carbon content in the product is very low. The carbon percentage varies from 0.07 to 1.7%.
Can you say, sir, the ancient process quality-wise comparable with the modern iron and steel processes?
As the product of ancient iron making process is concerned, it comprises of about 15 to 20% slag, and this slag is entrapped. It is almost uniformly distributed. It acts as a source for corrosion resistance, and this particular product cannot be compared with modern steel. Of course, it was the raw material for making world famous goods steel. The project documentation of ancient iron making technology and improvements in the existing process was taken up by National Metallurgical Laboratory, Jamshedpur in the year 1999. It was sponsored by Ministry of Steel, Government of India. Under the leadership of Dr. P.K. Biswas, this project was commenced in the year 1999, and a lot of assistance was provided by Professor P. Ramchandra Rao, the then director of National Metallurgical Laboratories, Jamshedpur. We invited a number of tribal artisans from Jharkhand state, and to start with, we have established a furnace, prototype furnace at Animal, and carried out experiments in their presence. After their departure, we could not reproduce the results, similar results, same product we could not make out. Then Professor P. Ramchandra Rao, then director, suggested us to go to tribal region in Jharkhand state and learn from them. Then again we visited the Gumla district of Jharkhand state. We contacted the tribal people, and again we carried out some experiments in their presence. We have measured the temperature with the help of thermocouple at different heights, and even also the weight from different intervals, whatever raw materials were added to the furnace, all those measurements were done. And thereafter, we could successfully produce similar product at our laboratory also.
Can we say that the process adopted by ancient iron makers was scientific?
During the investigation in first phase of the project, when we visited Gumla district of Jharkhand state and observed the practice of iron making by tribal people of Jharkhand state, we were surprised that they were carrying out the entire process very significantly, very scientifically, though they were not having any instrument for the measurement of temperature or the gas composition and so on. And when we carried out the similar, repeated the same experiments with the help of scientific with the temperature measurement and gas composition at different heights, we found the process is working very well. The only defect in the process is that a good percentage of iron is being lost in the form of oxide in the slag. Therefore, the recovery of the process is too less, that is 25 to 30% only. In the second phase of the project, it was given by the then Secretary, Minu Singh, the Secretary, Ministry of Steel, Government of India. She had sponsored the second phase to NML for further improvement. In the second phase, we have invited the tribal people from Bastar district of Chhattisgarh state, and they, as per the instruction of Ministry, we should involve tribal people also during these improvements experiments. We have scaled up the furnace to 6 times, and we tried to make lot of improvements. Instead of 1 tour in the furnace, we had 3 tours, and we have tried to automatic, semi-automatic also. We tried to recover the sensible heat of the gas which was going out from the furnace, and the hot blast temperature was maintained around 120 degrees centigrade. As a result, the recovery of iron, which was earlier 25 to 30%, it became almost double, 52 to 55%.
That's a great achievement, from 25% to 52%. Let us try to understand from Dr. A.K. Vash what future he sees for this process.
So, we can only say that this process is no doubt very good. The product is of high quality, and when we think that how to continue this process in future also, then the only point comes to our mind that Government of India should come forward to sell this product, to commercialize this product in foreign countries. Otherwise, it cannot compete with the present day iron and steel economically. Since this product is of special importance, it has got a lot of corrosion resistance, so a lot of decorative articles can be made and they can be exported to different countries. In this regard, government cooperation is extremely needed.
The process was so nice, but why not it could survive?
In early days, its product wrought iron was made use of for making household implements, agriculture implements and weapons, etc. But gradually, with the development of modern iron and steel industry, it could not survive, it could not sustain. The reason is that the recovery of iron by this process is too less. It is 25 to 30% only.
Question is that what is the significance of the ancient technologies that were used to manufacture iron as compared to the modern technologies that we are using for the iron production?
In present day context, the ancient iron making technology is not of much relevance except that it is being protected from the point of the heritage of India by present generation. And there are still lot of scope for the improvement of this existing technology which is there for last several years, for thousands of years. At small scale, this technology is not economical.
Sir, could you please tell us how did iron technology flourish in India?
This technology was, I will say, available in almost every part of India, in some way or the other. If you look into the Agaria book, you will find that the Agarias, where they have shown only the Madhya Pradesh, wherever raw material was available, I will say this technology was available. Bihar was probably the big originator of the iron technology, particularly because in Bihar you will find red mud or red earth everywhere, iron containing bearing, and for iron making we know that we don't want very rich iron ore for ancient technology. It is made from rather limonite, which is a hydrated iron oxide containing only 30 to 40% iron. That suits better than the hematite stone. Other part of the world, what I have found and what I have concluded in one of my papers, that is the iron technology was taken from here to Asian people went to western side, and the Syrian people carried the steel making, they carried the iron making also. Chinese people were the first, they were visiting India very often and they learned this process and they introduced their own process, but there they did not prevent the liquid iron making. And in Japan, they used modified furnace, larger furnace, and Japan is an example where it could produce 3 tons of steel in one heat.
Sir, as compared to ancient days, now so many technologies were developed. Still, why the modern world is unable to produce the iron which is having that much quality of as compared to the ancient days?
The Wood's steel sword was very uniform in structure, and they could produce structure controlled swords. That is why it became very famous as compared to the pattern welded sword. Microstructure study, you find rosettes of these formed by the distribution, radial distribution, you can say, of carbide, this cementite, carbide, spheroids and multifaceted, and they were normally they have been found in particular rows, and then some leaving some space, again row. So it is some people have called it ladder pattern, because you can see it just as a step